Hello, good afternoon to all. In today's class, we will solve a few problems on interpolation. So once again, I will follow the book by S.S. Sastry, and just give me some time so that I can join. Okay. Okay, so first we will focus on the concept called interpolation. So first of all, it is necessary that what is basically called by saying interpolation. So the statement y equal to fx, x0 less than or equal to x less than or equal to xn means, I will just discuss the brief theory for half an hour. Then I have some problems, we will solve those problems, and I hope that you have watched all the videos of Professor Jitendra Kumar. Okay, so consider that y equal to fx is a single valued and continuous, and what is one that if you have y equal to fx, you know this function explicitly, then for any set of tabulated x values you can compute directly the functional value at that particular point. But the central problem in numerical analysis is that the converse one. That means if you have known explicitly the ordered pair x0 y0 x1 y1 up to xn yn, that satisfies the following relation y equal to fx, where the explicit nature of fx is not known. It is the required to find a simpler function, say phi x, such that fx and phi x agree at the set of tabulated points. Such a process is called interpolation. So such a process is called interpolation. So there is a fundamental difference between interpolation and approximation. what happens in approximation, you may have error at the given points also. But what happens in interpolation? In interpolation, say y equal to fx is your unknown function. Instead you know x0, y0, x1, y1, xn, yn, and px be the interpolating polynomial. Then these points, at these n plus 1 points, px will be exactly equal to fx. So at those given values there will be no error. So this is the main difference between interpolation and approximation. Okay, sometimes if you want to appear in the interview, the interview panel may ask that what is the main difference between interpolation and approximation. So in interpolation, at the given points there will be no error, but in case of approximation there may have some error. Okay, next, so there is a very important theorem given by Weierstrass. If you have fx is continuous in this domain x0 less than or equal to x less than or equal to xn, then given any epsilon greater than 0, there exists a polynomial px such that fx minus px less than epsilon for all x in x0 x up to xn. That means that it is possible to find a polynomial px whose graph remains within the region bounded by y equal to fx minus epsilon, y equal to fx minus plus epsilon for all x between x0 and xn, however small epsilon may be. Okay, now we are mostly bothered about considering polynomial. Now why we are specifically interested in polynomials? Because polynomials are very nice functions, right? Why polynomials are so nice functions? Because polynomials have no problem in continuity, no problem at all in differentiability, right? So polynomials are actually very nice guys, nice set of functions. Next, errors in polynomial interpolation. So I will not go into the detailed derivation part. Follow Sar's note. So whatever numerical analysis we perform, we are always bound to do some errors, and now our aim will be to minimize the error. We want to learn numerical analysis so that we can minimize that sort of error. Okay, so this is the formula for error. I will not go into that details. I will just skip those things. I will just discuss two sort of interpolation formula. One is the divided difference, and then the Lagrange's method. So finite difference method are only applicable for equispaced data. Equispaced data means, what do you mean by saying equispaced? Equispaced means x0, x1 up to xn the gap between them are same. If you minus x1 x0 from x1, you will get h, x2 to x1 h, and xn to x minus 1 once again h. So this trend will be followed for all x0 up to xn. So then it is called equispaced. Now I hope that how to determine, I will just go into detail of, so mostly Newton's forward difference interpolation formula I will go first. Then similarly you can have backward differences also, where the differences are calculated in the reverse order. So how to calculate? See, here there are 6 points, x0, x1, x2, x3, x4, x5 and x6. Consequently you have, this is not y0, this is y. Consequently you have y, y0, y1, y2, y3, y4, y5, y6. Now how you will calculate the difference scheme? So first, this delta y0 means y1 minus y0. Delta y1 means y2 minus y1. Delta y3 means delta y2 means y3 minus y2. Delta y3 means delta 4 minus delta 3. Y4 minus y3. Delta y4 means y5 minus y4. Delta y5 means y6 minus y5. And similarly these terms can also be calculated by just subtracting the first one from the second one. So this is delta y0. If you subtract this from delta y1, you will get delta square y0. So this is how the difference table is formulated. So if you have 7 number of points, 1 2 3 4 5 6 7, then you can at most have up to 6th order difference. Okay. Did you got it? Then you can calculate this delta 6 y0. But it can also terminate somewhere. You can have at most, it may happen that here you get all these things equal. So that means these terms can become 0. But at most you can have 6th order forward differences if you have 7 equispaced data points. So one of the negative, you can say, one of the flaws of this forward difference scheme is that it can be only applicable to, it is only applicable to equispaced data points. So there is a, similarly how to calculate backward difference. Backward difference is also same, but here you have to calculate them in the reverse order. Okay, so how you will calculate? You will y6 minus y5, you will get this nabla y6. Just check. So nabla y6 is y6 minus y5, nabla y5 is y5 minus y4. That is how you will go. And similarly here also you can have up to 6th order derivative only, difference only, sorry, I am saying derivative. Central difference, it is not necessary for us right now. Okay, we will just skip this and please go through this SS Shastri book. I cannot, it is impossible for me to discuss everything. I think that I have uploaded this book in the NPTEL platform, such as this topic. This topic is very useful. Detection of errors by use of difference tables. Using difference table, you can identify in which you have error. just observe one thing, that here suppose that there is an error of plus 1 unit in a certain tabular value. Here is a error. Now you see how this error gets magnified. In this table, all the errors, the error is magnified in the central part. See, 10, minus 10, 5, minus 1, minus 5, 1. So it has, this is called magnification of error term. Just read through this example. This is also very nice example. Okay, next I will go through, that is called Newton's forward interpolation formula. So how this formula is made? So Newton's forward formula is you need to determine, interpolate. You have up to x1, x2, x3 up to xn, x up to starting from x0, then y0 up to y1. That thing you have. Now what will be Newton's forward interpolation formula? The nth degree polynomial y and x will be y0 plus p delta y0. Here p is actually x0 plus ph. Okay, x0 plus ph. That means your x is 0, actually x0 plus ph. Next, so that is how your formula looks. It looks y0 plus p delta y0 plus p into p minus 1 by factorial 2 delta y0 and so on, plus nth order p into p minus 1 up to p minus n plus 1 by factorial n into delta ki power n y0, and the consequently the error term will looks like this: yx minus ynx will be x minus x0, x minus x1 up to and so on x minus xn by n factorial into yn plus 1 xi. This xi is point in between x0 and xn. Next we will similarly you can also determine Newton's backward interpolation formula. Newton's backward interpolation formula is yn, so that starts from y0, that will start from yn, p into nabla yn plus p into p plus 1 by factorial 2 nabla square yn, p into p plus 1 into, and here what is your x? Your x is xn minus ph. See, x equal to xn minus ph. So forward difference and backward difference, why we need to learn these two things? First of all, in forward is useful if you want to, if your x lies near to x0, and backward if it is more near to xn, then you construct the difference table with respect to xn. Now see, find the cubic polynomial which takes the following values: y1 equal to 24, y3 equal to 120, y5 equal to 336, y7 equal to 720, hence or otherwise obtain the value of y8. Okay, it is very easy, but still we will go. So you have, first of all, you observe that this x, y, delta, delta square, delta cube, they are actually equispaced. How? You see that 1, 3, 5, 7, the difference between them are 2, 2, 2, 2, 2. Okay, so for 1 it is 24, it is 120, 536, 720. So how you will calculate the forward difference? So forward difference, just 120 minus 24, you get 96, 336 minus 120, 216, 720 minus 336, you get this. Then from these two, this 96 and 216, you get 120. From 384 minus 216, you get 168, and finally you compute this 48. And what is your x? Your value is y8. So these things are called extrapolation. This is called rather extrapolation, because you see your 8 is lies outside the x equal to x0 plus ph. H is 2, so x equal to 1 plus 2p. So how you will calculate this p as x minus 1 by 2? So 24 plus x minus 1 by 2 into your 96, then p into p minus 1 into 120, and then p into p minus 1 into p minus 2 by factorial 3 is 6, into that finally you get 48. You perform a few calculation, you get this cubic interpolating polynomial, and then finally you have x equal to 8. You put x equal to 8 there, you will get this process of finding a value y outside the domain is called rather extrapolation. Next, values of x in degrees and sin x are given in the following table. X in degrees, sin x is there. You need to determine the value of sin 38 degree. So once again they are equispaced. What you have to do? That is a very nice problem. Once again the thing is same. You need to calculate the difference table, okay, but here see this 38 degree is close to the, your 38 degree is close to the 40, this 40 point, this 30 is close to 40, so you will use backward difference formula. So how you have to calculate the difference table? You need to calculate, just to apply the formula. How the formula will look? The formula will be the interpolating polynomial px will look like yn plus p into nabla yn plus p into p plus 1 by factorial to nabla square yn plus and so on, p into p plus 1 into p plus 2 করে p plus up to আসবে p plus 4 nabla by y. That will be the answer. And what will be your p? This p is nothing but xn minus x divided by h. And that is how you can calculate finally just by putting 0.615614 that as the final value. Next, you need to find the missing term in the following table. Find the missing term in the following table. So your x, y 0 1 0 3 2 9 3 and then 481. Okay, what is happening here? You just see this is the function is basically just y is actually 3 की power x, but you need to see here 0 3 की power 0 is 1, 3 की power 1 is 3, 3 square equal to 9, 3 cube equal to 27, and 3 की power 4 equal to 81. You need to use backward difference interpolation formula. For that purpose you just need to calculate the difference table, and then you will get the final answer as this will give you a 31. Why? Because you are approximating this y equal to interpreting this y equal to 3 using a cubic polynomial, and for this reason you are getting the answer to be 31. This is because you are interpreting 3 की power x using a cubic polynomial, but 3 की power x is actually an exponential polynomial. Exponential function. That's why we are committing the error. Next we will move to, there is large set of problems in numerical analysis. You need to solve these on your hand, otherwise you may fumble. So it is necessary to just not to calculate actually. Okay. Next we will move to a concept called, there are many things. So till now we have whatever say we got the points to be equispaced, but in reality the points may not be equispaced, and for that purpose interpolation with unevenly spaced points is also quite natural, and for this purpose there are many methods. So those main methods are mostly Lagrange's method, Hermite's method, Newton divided difference method, and Aitken's method. I will not go into the theory part detail. Rather I will focus broadly on a problem. So see how the interpolation formula looks. Lagrange's interpolation formula. I hope that you are watching SAT's video, but still I will just like, you have x0, x1, x2, y0, y1, a2, and they are not non-equispaced. That means x1 minus x0 is not equal to x2 minus x1. One of the advantage of Lagrange's interpolation formula, if you have the y value given and you can just determine the x value corresponding x value also, that thing is called inverse interpolation formula. You can use Lagrange's method to do that thing also. Okay. So next, how to do? For this purpose you need to calculate the weight functions. It looks quite scary, but it is actually not. Okay, there is at least some easy problem. Find the Lagrange interpolating polynomial of degree 2 approximating the function y equal to ln x defined by the following table of values. Hence determine the value of ln 2.7. So first L0x, that means this is your x0, this is x1 and this is x2. So the formula for L0x is x minus x1 x minus x2 x0 minus x1 and x0 minus x2. These are called weight functions. Now I will giving you one important task. For any, the advantage of Lagrange's interpolating polynomial is that it can be applied to equispaced data points also. Now consider any problem, you apply Newton's forward divided difference formula, you apply Lagrange's method, and you can check that both the polynomials actually looks same. So there is a theorem that the interpolating polynomial, if exist, is unique. Okay. So just calculate this L0x. Similarly, you can calculate L1x, L2x, and then what will be your Lagrange's L2x? Just L0x into y0 plus L1x into y1 plus L2x into y2. This will be the final Lagrange's interpolating polynomial. And ln 2.7 तो आप एरर भी निकाल सकते हो. यू कैन डिटरमाइन द एरर ऑल्सो. ln 2.7 से आप माइनस कीजिए, यू विल गेट द एरर, वेरी मिनिमल एरर. Similarly, you can also a few problems also. You can also few problems. You can also like you can also I will briefly discuss about the error in Lagrange's interpolation formula. The error in Lagrange's interpolation formula, say y equal to ln x. So you have 3 points, it is given. So what you need to determine? You need to determine third order derivative of y. So y triple prime xi is 2 by xi cube, and between 2 to 3 the continuity and the derivatives, continuity of the derivatives are satisfied. So Rn x will be x minus 2 into x minus 2.5 into x minus 3 by factorial 3 into 2 by xi cube. So 2 by xi cube. Then 2 by xi cube, this is a monotonic decreasing function. So 1 by xi cube will be less than 1 by 8. So the error will be less than 0.000175, and you can observe that this error is actually less than that theoretically computed one. It is a very nice problem. Okay, up to that we have discussed. Next we will be moving towards the thing of our problems. Next, let fx be a function. So this is probably 2 years ago the problems, so we will discuss them. Let fx be a function defined on the interval -1 to 1 such that f of -1 is 5, f of 0 equal to 0, f of 1 equal to 3. The quadratic polynomial px which agrees fx for -1 0 1 is 4x square minus x. If d cube x dx cube f dx cube less than or equal to 1 by 4 for x belongs to -1 to 1, then max of f. That means you need to calculate just error, right? And error is same, just I have discussed for Lagrange's interpolation formula. So that will be x minus -1 x plus 1 into x minus 0 into x minus 1, then f triple prime xi, f triple prime xi is less than or equal to 1 by 4, so this is less than or equal to 1 by 4 हमने कर दिया. Then it gets x cube minus x by 1 by 6, so that means 1 by 24, max of x cube minus x. Now how you can determine the maximum? G equal to x cube minus x, then g prime will be 3x square minus 1, and 0 x equal to plus minus 1 by square root of 3. So that means max of modulus fx minus px, this is less than or equal to 1 by 24, 2 by 3 into square root of 3 equal to 0.016. So that is the answer. A very nice problem, and hope that it is understandable to you. Just I have discussed right now the same problem they have given in the assignment. Next, which of the following statements are true for the approximated polynomial px of the function fx defined on the interval a comma b? For n plus 1 data points of fx we get a unique polynomial of degree n. For n plus 1 data points of fx we get a unique polynomial of degree n plus 1. The polynomial px satisfies this, the polynomial px satisfies this. Just we have discussed that the interpolating polynomial if exists is unique, so a is true, and the polynomial px satisfies fx minus px less than epsilon for all x a comma b. So d is also true because this is straightly follows from Oester's approximation theorem. Next problem. The second forward difference from the following table: x fx 0 1 2 9 18 20, 0 1 comma 2 9 18 20. Forward difference will be 18 minus 9 will be 9, 20 minus 18 will be 2, and second means 2 minus 9 will be minus 7. So minus 7 is the answer. Very easy problems, right? Just giving 2 minutes to you to digest. Okay, next problem. The third backward difference from the following table. Third backward difference also आपको क्या करना होगा? First of all you need to write, so delta fx1 will be how 115 minus nabla fx3 will be 115 minus 73 42, nabla fx2 will be 73 minus 38, that will be 35, 38 minus 8 will be 30. Then nabla square fx3 will be nabla fx3 minus nabla fx2, so 42 minus 35 will be 7. Nabla square fx2 will be nabla fx2 minus nabla fx1, 35 minus 30, so that will be 35 minus 30 will be 5, and then finally subtract from this, so that will be 7 minus 5 equal to 2, so the answer will be 2, answer C. Next, can you solve it? The option, the answer is B. I am giving you 2 to 3 minutes, just solve it. Okay, so you have x 20 25 30 35, fx 30 76 61 51 46. So that will be minus 15 minus 10 minus 5, then minus 10 minus 15 will be 5, minus 5 minus 10 will minus of minus 10 will be 5, 5 minus 5. So जो मैंने आपको बोला था लास्ट टाइम, है ना, क्या बोला था मैंने कि नेबुला क्यूब एफ, देखो 4 पॉइंट, देयर आर 4 पॉइंट्स, द वैल्यूज आर स्पेसिफाइड बट इट मे हैपन दैट it is vanishing well before, so you can only construct a quadratic polynomial only. So the quadratic polynomial will be, sorry, cubic polynomial only. So you can, sorry, quadratic polynomial only, because this last term will vanish. So that means fx0 plus x minus x0 lambda of fx0 by h, and that is how you can actually get your p3x, and your p3x you will, मैंने एक p, we have considered p and also calculate, you can use that method also. So this will be your final answer. Next, next problem. The value f for 4.5 using Newton's backward interpolation formula for the following data: 3 4 5 10 17 30. So 3 ही पॉइंट है ओनली, fx equal to 10 17 30, 30 minus 17 13, 13 minus 7 will be 6. So next p2x will be fxn plus x into x minus xn nabla fxn by h plus x minus xn minus 1 nabla square fxn by factorial 2h square. So you have calculated this as nabla fxn, this is a nabla square fxn, you know the values, put them up and you can get this as f 4.5 as 3x square minus 14x plus 25 to 22.75. Which of the following options is are correct for the following table? fx1, acha, I have not discussed divided difference, okay, but still I will I hope that you have watched SAT's video. So what happens in divided difference? This is also applicable if your points are non-equispaced. So you have 3 5 8, so they are non-equispaced. So how you can calculate the divided difference? So first f53, this is a notation for divided difference. This is the formulae that f of xi plus 1 comma xi equal to f of xi plus 1 minus fxi by xi plus 1 minus xi. So that will be f5 minus f3 by 5 minus 3. that will be 33 minus 5 by 2 will be 14. F85 will be F8 minus F5 by 8 minus 5 will be 120 minus 33 by 3 will be 29, and then F853, this is just F85 minus F53 divided by 8 minus 3, so that is just 3. So your answer is 8, F853 equal to 3 and F53 equal to 14. The Lagrange's interpolation polynomial for the following data points: x, fx, -1 0 2 -8 3 1. आपको तो Lagrange तो पता ही है कैसे करना है, I have already discussed. So the Lagrange interpolation polynomial for 3 data points, you have 3 data points. So you have x square. So first you need to calculate L0x, L1x and L2x. So that is x minus x0 by x minus x2 fx0, x0 minus x1, x0 minus x2 fx0, x minus x0 into x minus x2 by x1 minus x0, x1 minus x2 fx1, and then that will be L2x will be x minus x0, x minus x1 by x2 minus x0, x2 minus x1 fx2. So next you know your x1, x0, x1, x2. See here it is also non-equispaced. Then put the values here, calculate them up, you will get minus 4x square plus 7x plus 3 as the Lagrange's interpolating polynomial. Next there are two methods for integration, that is called trapezoidal and Simpson's 1/3 rule. In the next class I will discuss about trapezoidal method and Simpson's 1/3 method. So till now, so thank you very much for watching my YouTube video, and hope you have enjoying the series. So we will discuss the next part of the numerical analysis in the next class. So till then, bye. Thank you very much.